It's wrong. I put the 3 instead 13.
Ah, thank you. I was thinking it should be the 20%.
Yeah, 0.1780.
That's better.
Yeah.
So 17.8% roughly.
Mhm.
Okay. Oh yeah, and I forgot to do this too. Oh geez, so many little things. There we go. Okay. You guys doing okay out there? Hello? Hello?
Yes.
Is
it's
it
good.
math you're looking for? Okay. Stop sharing. All right, guys. Anything else before we get back into factoring? Factor. What's that factor? All right, let me see. Where is this thing? I'll let you guys think for a minute while I look up my sheet. Here we go. Perfect. Bam. Factor.
So, Professor, I have another question, maybe too much, but this one is confusing for me.
Yes.
Question number 9, page 529.
Oh, so this is exactly just like the lizard problem, right? Write a functional format or the expression. All right. So how much is he making at the beginning? What's the initial amount?
In question number 6, that's me.
Where are we at? Number 9. So it goes all the way back to the beginning, right? How much is he making initially? $30,000.
30,000.
And how much does that increase by every year? Just like the lizards, right? Just like the lizards. 30,000 lizards, and how many more lizards do we get each year?
40%. No, this
4%.
rate is not.
4%. Yeah.
Okay.
Okay. So now you just got to throw it in the right place. Right? So we got Shisa, we got this, we got. So now if I want to use their function notation, f of x equals a times 1 plus, get out of there, a. I want to throw an a in there. P times 1 plus r to the x. I want to make it x instead of t because they just want me to use x. So what goes here? What goes here?
30,000.
30,000. 1 plus what goes there?
0.04.
I like it. To the x. There you go. Done. That's your function. Where x represents years after age 30. So some of you guys are doing some weird things with x, but it's like if he's 60, then that x should be 30. Years after age 30. Do you guys see how that's just like the lizard problem? My initial amount, my percentage change, just throw them in the right place.
And this question finished here.
What's that? Sure.
This question finished here. I'm no one looking about the x because we don't know the
I don't
x.
understand. So this number 9 is done. That's all I want. Yeah.
Okay.
All they want you to do is write a function of the form this.
Okay.
We did. Yay. Now number 10 says, what about when he's 60 years old? And you got to use your function to figure out an amount. Yeah.
Okay.
Okay. I like it. Gosh, I don't know how much I was making when I was 30. Not like a ton. I think about that much. Yeah. All right. All right, guys. Let's see. Let me know if there's any more questions. I really hope most of you are out there. So yesterday, I wasn't smart and I did this a different way. So I don't have the work up here that we did yesterday, but just to kind of remind you guys, we did this stuff up here yesterday. So like multiply to 24, add to be 11. Remember we got 8 and 3, right? I'm just going to kind of catch up to what we did yesterday since I didn't have this written down.
Yes,
Negative 40, add to be 6. We got 10.
10 and minus 4.
Good. The 4's got to be negative to make it positive 6. Multiply to 56, add to be negative 1. So they got to be 1 apart. 7 and 8. And the bigger one has to be negative.
Minus.
All right. So it might have at the beginning seemed like, well, what's this all about? We're just playing around with numbers. And because this is a specific skill we need to have, let's do these other two here real quick. So just to remind you guys, we did this one, we did this one, and we noticed that 2 plus 8 is 10, and 2 times 8 is 16. 4 plus 5 is 9, and 4 times 5 is 20, right? And if you think about it, that's exactly sounds like this first set. 2 numbers that multiply to be something and add to be something. You got to let me know if you're not with me out there. So just to do these real quick, x squared minus 2x minus 6x plus 12. So x squared minus 8x plus 12. And sure enough, negative 6 plus negative 2 is negative 8. And negative 6 times negative 2 is 12. So the pattern still holds. All right, I think I don't have to do that. Oh, you're still doing the wrong way, Jeff. Oh my God. All right, sorry. Oh, geez. All right, so this is all going to disappear. Someday I'm going to realize which button to push. All right, so let's look at this. I think, so again, I really want this to be so nothing but beautiful here. I know that x times x gives me x squared, correct? So there's no misunderstanding there. It's just x and x. Because the problem is the minute you bring numbers into play, well, a bunch of things multiply to be 12. But what also adds to be 8? Right? So that's why, so I want 2 numbers that multiply to be 12 and also happen to add to be 8. What are those 2? I think we did this one.
6 and 2.
6 and 2. So 6 and 2. So that's the answer. And we can check it. X squared plus 2x plus 6x plus 12. So do you see why it makes sense that this is the answer? Because 2 and 6 make 8. That's the middle term. And 2 times 6 made 12. That's the last term. So that's why this skill here is so necessary, because that's exactly what you got to figure out. It's a little number puzzle. Are you guys? No idea how you guys are feeling right now. Zoom, I hate you. All right. So can somebody tell me the 2 numbers I need for this one? So I know I can put, so here's the idea. I know I could put x and x because that's how I get x squared. So the whole problem is, what do I put here and here? So what do those 2 numbers have to do? What do the 2 numbers have to do? They have to
Add up to negative 12. And
add to negative 12.
And multiply to 20.
Multiply to 20. So it becomes a number puzzle. Since they add to be negative 12, but since they multiply to be positive 20, can they be different signs?
Yeah, negative 2 and negative 10.
Let me ask the question again. I love you so much. You're answering a question I haven't asked yet. Since they multiply to be positive 20, can they be different signs?
No, they have to be the same.
They have to be the same sign. Since they add to be negative 12, they have to both be negative. All right, so like, I think it was Alariza who said, did I get that right? Minus 2, minus 10. Doesn't negative 2 and negative 10 add to be negative 12? And don't they also multiply to be 20? Yes, do you guys see that? So what's, if I can't just sort of suddenly see that, so I can just write down 20. 4 times 5 is 20. Do they add to be 12? No. Right? I can just kind of, 1 times 20 is 20. Do they add to be 12? No. 2 times 10 is 20. Do they add to be 12? Yes. And they both are negative to make them add to be negative 12. How are you guys doing out there? The only person I see is not looking at me.
Yeah, sorry, Professor. I'm dealing with something from work right now. My boss is texting me.
I'm sorry, buddy.
No, it's okay.
I'll try not to take that personal.
It's not, yeah.
I don't
Sorry.
pay you, so I guess. How's everybody else? Are you guys? I have no idea how you're feeling. Are you just going, well, this is only going to be 1 or 2 questions, so I don't understand this for shit, so I'm not going to say that. Or do you understand?
This makes a lot of sense to me, just because I know you didn't like it yesterday, but it comes in a case with the like magic X that
No, that's fine.
Yeah.
Here, you help me, because I always forget how the X, but isn't the X asking the same questions?
Yeah, it's the same thing. It's just, I think it's just like a compact way of like doing it.
Yes.
Like,
so help me out. What would I put in the X for this one?
All right, so you have the negative 60 on top.
On top. So they have to multiply to be negative 60.
And add to be negative 11. And that would be
so it takes a little while to, yeah, this one's not an immediately obvious one, is it?
I think these are so fun though. It's like a little puzzle.
That's what I'm trying to say. It is a puzzle, and I know some people hate puzzles, and some people like, well, some puzzles will take you to hell, Jeff. Have you ever seen Hellraiser? I'm like, this is not that kind of puzzle. Not going to tear the walls apart.
It's a little circle. It's a little
yeah. I know the 2 numbers. We have such sights to show you. I'm like, oh my God. Sorry, everybody, if you've never seen Hellraiser. Okay, I'll stop talking. Now let me help a little bit. All right. Has anybody else ever seen this kind of way to put this? Have you guys ever seen that?
Yeah, like a very long time ago.
Okay. For some reason, again, it's kind of like, I don't know why. There's something psychological about it. It makes students feel like it's easier if you put it down in this X. And I'm not going to knock that. I'm also not going to teach that. Even though I just admitted that it seems to make students understand things better. I don't care. I do care, but what's more important than the way you write it down is the idea behind it, right? So you write down what it multiplies by, what it adds to, and I just wrote that down here in a little sentence. Then you got to figure out what 2 numbers make both of those. Oh,
Can I say?
no, don't say.
Okay.
So one way to do this, let me show you the opposite way than what is traditionally shown. Don't I need 2 numbers to add to be negative 11, correct? So give me 2 numbers. No, let me see. All right. I don't want you to give me the answer. So for example, and don't they have to be, what kind of, do they have to be the same sign or different signs?
Different.
Because they multiplied to be a negative number. So they have to be different signs. So in that case, wouldn't 17 and 6, doesn't that make 11? Negative 11, right?
Yes,
But
but it's not correct answer.
I know. See, I'm doing like building up to the answer. So, but if you multiply those, you get 102, I think. Sorry. Okay. I really want you to understand what I'm doing. So I'm making a list of numbers that make one of the 2 things happen and then check to see if the other things happen. So isn't that way too big? I wanted it to multiply be negative 60. That's way too big. So let me go down to negative 16 and 5. Do you see how that still adds to be negative 11, everybody? So I made that part work, but when I multiply them, I get negative 80. I'm getting closer. All right, now
It's gonna be 80. Yeah.
tell me, what is it?
Oh, can I say?
Yes.
Oh, negative 15 and 4.
Yes, because when you multiply those, you get negative 60. So then I know, God, I really put a lot of shit down here, don't I? Let me see. So then I know X and X. So the whole number puzzle thing that we just did is to figure out what numbers go here, right? So now I can put minus 15 plus 4. And if only there was a way to check, oh yeah, I can. I could just multiply the shit out and make sure it comes out to be this, correct? Okay, I'll take that as a yes. Okay. Let's see. I didn't really, all right, you guys, all right, we'll do D in a minute. Try part E. Do part E. I'll just sit here. I really like when the,
All right. Oh, sorry. I got
got
it.
the answer?
Yeah.
All right, hold on to it. I really like when the middle number is a 1. Because then I know I need two numbers that are 1 apart, like 6 and 5, 7 and 8, or maybe even better,
Oh, 8 and 9.
8 and 9, right? So I guess you would do this, right?
Yeah.
And of course, which one's negative?
The 9.
The bigger one, to make sure it adds to be -1. So it's not like all this stuff to memorize. It's all the stuff trying to help you. Oh, it has to add to be negative. Okay, so the bigger one's negative. Bam. So now what goes here and here?
That's A.
A,
Good.
A.
I got 2 A's, so I can put 1 A in each place.
Yeah.
Does it make, I got 2 A's, so I put an A there, A there. That would give me A squared when I multiply.
A plus. And then 8. A minus 9.
Yeah. The letter A is bad for me, especially when there's 9s running around. Okay. I have no idea how you guys are feeling. All right, we'll come back to D, but look at F. Look at F. Think about it for a minute. Don't say anything. Okay. Does somebody have an idea what the answer is for part F?
Well, I sent you a message, but
Well, something
don't-
does. You're wrong. What 7 times 1?
but
But
no, that doesn't add to make 3.
doesn't make 3. So the only possible way to break 7 up, and we deal with integers, whole numbers. Thank God we're not going to try to break it up into fractional parts. Holy crap. So what do you call a number that you cannot factor except for 1 in itself? Does anyone remember? These are numbers like 3, 5, 7, 11, 13. 2 is included in there too. No, what's going on? You guys don't remember? It starts with a P.
Prime number.
Prime. So we call this prime. Or you could just say not factorable. That's good. Right. So if I said factor 17, when you look at me kind of funny, factor 17, do it. You're like, I'm done. The minute you asked the question, Jeff, I was done. Man, because it's a prime number. I can't, it's just 1 times 17. There's no other way to break it up. So this expression is prime. There's no way to break it up in terms of whole numbers and variables. Is there a way to factor this? Yeah, but you have to use gross square roots and shit. You want to do that? No, I don't want to do it. So I won't do that. Now look at part D. What's different about part D? Why are you doing that, Joe? I don't know why.
Multiply and same. If you wanna add or multiply.
I'm not sure what you're saying. No, it isn't the same. There's a big difference. It is the only problem where something happens. None of the other problems has what part D has. What's the first number? What's the first coefficient in every other problem we did?
Oh, yeah, yeah. Here is 2. Yes,
So everything we do on these kind of problems
okay.
requires the first number to be a 1. Do you see that? So can I do this problem? Yes, we can. Is there a number that comes out of everything that I can like undistribute? Is there a number? Say again.
2.
2. So didn't somebody take a 2 and distribute it to what would have been here? If I would have 2 times what is 2x squared?
X.
Squared. And what's 8x divided by 2?
4. X.
And then 8 divided by 2.
4. Mhm.
Now, take a minute and do this. Don't say anything. This should be very quick. These multiplies before, adds to before. All right, what do you guys get? What adds to before and multiplies before?
2 and 2.
2 and 2. Neato. So this is fine. Or I could also write this like this. Watch out. Watch. Oh, shit. Right? Because I got 2x plus 2's multiplying. So I could write, this is fine. This is perfectly fine. Or you could be all nifty and do this. All right. So I want to give you a little motivation for what factoring is useful for, right? So watch this. What if I had this problem? Now, can somebody tell me real quick, a little side note, 3 plus 5 divided by 3. Can I cancel the 3's?
Yes.
What's the only time you can cancel numbers in an algebra, in an expression, is if the operations are opposites. What's the operation on the top?
Addition.
And what's this operation here?
Division.
So do those kill each other?
No.
No. In fact, what is 3 plus 5?
8.
And does 3 go into 8 evenly? No. So if you do this and tell me the answer is 5, that's some magic shit right there, right?
Right.
Tell me 8 divided by 3 is 5. No. Yeah. So do you see how I can't just like cancel an X or something weird to do 12 divided by 6 because there's all these pluses. The only way, but could I do this? What if I had 3 times 5 divided by 3? Could I cancel the 3's?
Yes.
All day. They can cancel because division kills multiplication. So have we developed a way to rewrite x squared plus 8 plus 12 so that it's multiplication? Didn't we rewrite x squared plus 8x plus 12? Didn't we? Isn't this the same thing as x squared plus 8x plus 12? Are you guys? All right, what's happening? We did this problem yesterday, and we
Yes, we did.
yeah, we did. So those two are equivalent. So I can rewrite this as x plus 6 times x plus 2 divided by x plus 6. And now what can I kill? Just like the 3. I
It's
can
plus
kill.
6.
X plus 6 dies. The answer is x plus 2. Okay. And again, I understand that's not fascinating, maybe. But I just want to show you this is one use for factoring, is for simplifying fractions with variable expressions. Okay. Let me do my weird little thing again. Hold on. Just deal with me. Deal with me. Here we go. And you're like, that's all I ever do, Jeff. Every day, I just deal with you. Okay. What if x, somebody give me a number for x?
6.
6. So what if x is 6? Then the top would be, I really want you guys with me. The top would be 36. Is that cool? 6 squared plus 48 plus 12, right? 8 times 6 over 12. So this would be, if you add all this together, what do I get? I think I get 96. Is that right? Yeah. What is 96 divided by 12? Somebody help me out.
8.
8. And didn't we just show that this equals this?
Yeah.
And if x is 6, what is this? If x
8.
is 6, this is 8. Hey, holy shit. So yeah. So when we do this kind of problem, we actually have reduced an infinite number of fractions. So over the last 2 days, we have multiplied an infinite number of things, we have factored an infinite number of things, and now we have divided an infinite number of things. Feels like we should be more tired, even though we are tired. We just did an infinite amount of work. That's crazy. All right. So I'm going to stop sharing. I'm curious. Let's go into the book, because I haven't really looked at the book much in terms of factoring stuff in this section. Let's see what the book does. Oh, Nikes. Where am I? Here I am. So I don't know how I feel about this person. I don't know. I don't like how they're making factoring sound so horrible. Blah, blah, blah. Look at all this weird shit. Oh, there's some music stuff. What's going on? Oh, God, no. Okay, let's see. All right, so it takes them a long time. All right. Oh, well, all right. All right, here we go. This is perfect. Okay, perfect. Perfect. Exactly where I want to be. So they give me this function, right? Take a minute, figure out. Go ahead and do all these 4 problems. Don't say anything. Just try to do it. So remember how function notation works. The number inside takes the place of x. So I just put it wherever there's an x and I figure it out. Okay. Oh yeah. So just to make sure you guys All right. Is that cool, this first one? So now if I do this one, replace X with -3. So this time I won't get 0. All right, and then two, this isn't too bad, I hope, right? Just plug a -1 in place of X. Gotta be careful, this isn't 0, this is -2. And of course, who's got part D? Did anyone do that yet? Okay, so hopefully that's not that horrible, right? Function notation is relatively simple. It's just substitution. Now, here's the bigger point. How many times did we get a 0 result?
Twice.
Two
Twice.
times.
Twice, exactly. And they corresponded to what makes this 0 and what makes this 0, correct? Doesn't 1 make this piece 0 right here? 1 would make that 0. So
Yes.
then it doesn't matter what the other piece is, does it? Because 0 times anything is 0. And the other thing happened when this piece was 0. And of course, -5 makes that 0. Who cares what this other thing is? The whole thing's going to be 0. So I'm going to clear all this away. You ready? Okay. If I have here if I have this, what do you got, Jeff? I don't know. I don't know, dude. Make something up. There it is, my friend. Okay. If I have this, can you factor this for me? Don't say anything. Just take a minute, see if you can factor it. I'll get it started. So what's it got to add? What do the two numbers have to add to be?
Can I say?
No, don't tell me what the numbers are. Just please answer my question. What do the two numbers have to add to be?
And -18.
No,
3.
3.
3.
Oh, am I looking in the wrong area?
maybe. So
Okay,
they have to add to be the middle, multiply be the last.
that's right.
Okay. Just because of the way that the multiplication thing works. The middle terms comes from adding the like terms, and the last term comes from multiplying the last terms. All right, let's see. Somebody said they have the answer, right? What'd you get? Oh, see, no, you ready? No, has anyone got the answer yet?
6 and -3.
-3.
Yes, good. 6 and 3, and the bigger one has to be positive. I like it. So the smaller one is negative. So that comes out to be +3. So when the last sign is negative, this sign tells you what the bigger one has to be. Because then that would make sure that it has that sign at the end. So now I can just put in here X plus 6, X minus 3. Now, can somebody tell me, based on what we did over here, what two values of X would make this 0?
I can see.
Say again, sorry.
-6
Good. -6, because that makes this piece 0.
and +3.
And +3, because that makes this piece 0. Do you guys see that?
Yes.
Okay. I like it. So to be honest, if I had a profit function, right? Profit function, if we do what we just did, it would actually find the break-even points. That is a process I would use to find when the output is 0, which in this case would be the break-even point, correct? When our profit is 0, break even. So this process here, one reason we could do it is to find the break-even point for our company. I like it. Okay, let me clear all this away. I know, man, I know. You're all like number puzzles and break-even points. Oh my God. All right, let me clear all this away. Clear. Oh. Who cares? All right. All right, here we go. Now let's, well, this is not too exciting. So based on what I just said, they give us this, which is so dumb. Why do they give us that? Can you just look at the graph and tell me where the break-even points would be, where the X-intercepts is another name for them? What are the X-intercepts? Can somebody figure that out?
0, -3.
Careful. That sounds more like a Y-intercept.
0 minus 4.
That is the
-3.
Y-intercept, but I'm asking for an X-intercept.
Oh.
So what point is this the an X-intercept? And isn't this one also? So what are those 2 points?
-3.
There we go.
And
It's
1.
turned the wrong way around, right? And of course, this one is
1.
now watch. You guys ready? You guys ready? Remember how we just did one, I think it was this, is that right? And we knew that it was -6 and 3 were the zeros, were what made it. Remember that? Remember? So now we know -3 and 1. Can you figure out just from that what the factored form looks like? -3 would make what 0? If it was X plus or minus something, what would -3 make 0? If it was X
+3.
plus 3, wouldn't that make it 0? Now somebody else tell me what would have to be here to make 1 make it 0? Like X plus 1 would make it 2. I want something that would make it 0 when I put a 1 in there. X minus 2, that would be -1 when I put a 1 in there. Come on, is anybody else out there? What's happening out there?
Yes, I'm here.
Nobody understands it? X minus 1, wouldn't that make it 0 if I put a 1 in?
Yes. you can.
And that is how I factor that. Isn't it? Multiply to be -3, add to be 2. Multiply to be -3, add to be 2. So that's the connection. When I factor something, the pieces tell me the X-intercepts. So if I know the X-intercepts, it actually works backwards and I can figure out what the pieces are. It kind of goes both ways. Okay, nobody likes that. Okay. All right. Let me clear all this away because it's bothering you guys. Clear. Blah, 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 blah. So here, real quick. All right, let's see who's got this. What X values would make this polynomial function 0? What would make this 0?
+3.
Yes. Is it my question you don't understand? If I make X3, wouldn't this be 0? Yes. Now somebody else, what would I make X so that this would come out to be 0?
4.
+4.
4 would make that 0, correct? 4 minus 4 would be 0. Those are the zeros. Those are so the x-intercepts are going to be 3, 0, because a 3 makes the output 0, 4, 0, because a 4 makes the output 0. That would be the intercepts for that graph, if I graphed it. So let's see, what would this kind of look like? It would have an intercept at 3 and an intercept at 4. And since it's positive, it would open up. So it'd be something like this. If I could just, I'll make that point bigger. Okay. I really want you to see the connection. And we all know there's a connection between an equation and its graph. So here there's actually some more connections. Go ahead and try this. What are the zeros of this? Don't say anything. Just try to list. Zeros are just the values of x that would make the output 0. So there should be 3 answers here. Don't say anything. All right, who's got the, give me one answer.
-5.
-5. Somebody else tell me another answer.
-4.
-4. Now somebody else tell me another answer.
2.
2. Yeah, there you go. And so that would translate into -5, 0, -4, 0, and 2, 0. I like it. Oh, okay. Let me see the chat. Okay, thank you, Guillermo. Sorry. All right. Let me clear all this away. Trying to think, how can I be more boring? Let me think. I'm a math teacher. It is in me, this innate ability to be boring. Okay, let me clear all this away. I'm not being boring enough. Let me see. Oh, let's see. How much deeper do we want to get into this? Let's see. Blah, 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 blah. Oh, they're finally building their way up to doing this. Oh, finally. Thank you, book. Okay. So, I mean, this is all the stuff we've already done. Do you see this? Where, well, how would this factor? I need 2 numbers that do what?
If we multiply 6 and if we add it 5.
Yeah, and what multiplies to 6 and adds to be 5?
2 and 3.
2 and 3. I love it. So it'd be x to make x squared. 2 and 3 to make 6. And of course, they make 5x when I do this. Bam. Yay. Okay, that's it. So the book is finally catching up to us. I like it. I don't think they do too much more. Let's see, this is one like we did where you had to factor 2 out. Remember that? Like we did. This one's gross. Oh no, wait a minute. I'll get out of here. I'm not gonna worry about it. Oh no, this gets really neat. All right. All right. I'll tell you what, we'll do this one tomorrow. I think I've put you through enough today. Yeah, sure. That's enough for today. So continue catching up in chapter 4 homework. Bring, not tomorrow, you know what I mean. Tomorrow's Friday. Don't come tomorrow. Monday. I think the practice final is accessible on Canvas, so you can try that out. Next week, we're going to finish up chapter 4, and then we're going to devote the rest of the week to reviewing for the final. All right. So that's enough for today.
And
Let me
that
know if you have
was,
any questions. Sorry.
that was until midnight, right?
Yeah, the quiz. Wait, no.
It's 10 o'clock. 10 o'clock tonight.
10 o'clock. Yeah.
Okay.
Cool, cool, cool. So a few people have done the quiz already, so the rest of you guys get in there and do it. You're
Hey,
welcome.
Professor.
Yeah.
So can I ask you one thing? This shouldn't take long, really quick. So my grade or my test average is an 84%.
Okay. Sure.
And then my midterm, I got an 80.
Okay.
So would my grade probably be, let's say with zero homework, my grade would probably be in like, I don't know, 78%. Around
You're
there.
just totally guessing about that, or did you?
Yeah, I
actually...
totally guessed on that.
All right, so that's a bad idea. All right,
Okay.
so let's see. So if you take, so what was your quiz average again?
84. It was like, yeah.
So do like 0.3, just to kind of assume the worst. Do 0.3 times 84.
0.3 times 84. Okay.
Plus 0.2 times
0.2
your midterm, which was 80.
80.
Okay,
Yeah. Equals 50.
No, don't worry.
Okay, I was like, that's really low.
Now listen. Now divide by the percentage we put in there, which is 50 total percent, right? We did 20 and 30. So divide by 0.5.
Divide by 0.5. I must have done something wrong.
I think so, because you said like 50 something. Let's see. So 0.3 times 84.
0.3 times 84.
Plus 0.2 times 80.
0.2 times 80. Okay.
Equals
57.2.
57.2.
Let me write this down instead. I'm so sorry.
Oh, that's all right. That's all right. Let me show you on my calculator. Let's see where you guys at. There you are. All right. So 0.3 times 84.
Yeah.
Plus 0.2 times, what was it? 80?
80.
There we go. Divided by 0.5. Yeah. So you have an 82.4 right now, roughly. That's not including homework. So if you turned in a bunch of your homework, it'll definitely be higher than that.
Okay. So this is not including homework.
No, obviously not. We didn't include any homework in there, did we?
But let's say that there was zero homework turned in all semester.
Oh, okay.
Then it would be.
All right. You ready? Let me
Yeah.
see. Give me a second. Let's see. It would be, all right. So it'd be 41.2 divided by about 0.53. No, that's not right. Oh, I hit times. You gotta love that shit. Divided by. So yeah,
Okay.
divided by a little bit more, like, anyways, weirdness. So yeah, you came out right. So you said 78.
Yeah, I said 78. That's pretty good.
Good intuitive grasp of mathematics. I love it.
Looks like I should be having the math degree.
You should be,
that.
man. You should be teaching this class. What am I doing? I am a poser. I'm a poser. I'm a wannabe.
All right. Well, thank you so much, Professor. That really helps me out. I needed to get a good gauge on that before
You're welcome.
I have a meeting with my counselor in an hour, and I wanted to give some good news about it. So thank you so much.
Sure. See you. Trisha, are you out there? You okay?
Yeah, I'm here. I have a couple of questions because I'm lost. And I sat with a tutor, and I think he just confused me farther. I've been struggling with like the like scales and like so one of the biggest things was like 4-2, like it was it was like 2 and 3, and it was like feet and distance, and I think that was the Pythagorean theorem, question mark.
No, not number 2 yet. Number 2, hold on. All right, here we go. This problem here, right?
Yeah, so I've been struggling with those.
Listen. Oh yeah, number 2 is all right. Find the grade of the trail. So that's not distance, that is slope, right?
Okay.
Okay. So tell me this. So in number one, well, actually not, sorry. Number one is about point A. This is about point X and Y. So how high is point X?
1,500 meters.
Okay, good, 1,500 meters. And how high is point Y?
2,250 meters.
Good, 2,250. So now listen, do you remember grade is the same as slope? We talked about that for a little while, like a 7% grade is 7/100, which is rise 7, run 100. Do you remember that?
Kind of.
All right, so grade of a road or of a trail is just the slope. How much do you go up versus how much do you go over?
So you would go up 1,500 and over.
Stop. So if I start at X and go to Y, how much
Uh-huh.
did you go up? We started at 1,500 and we got to 2,250. So how much did we go up?
Oh. Oh. 750 meters.
Good. And how much did we go over?
5,100 meters.
Good. So isn't that rise over run? So if you divide those two, you get the grade. You get the slope. So grade is what we call
okay.
slope, and when related to roads and trails and stuff, we call it the grade, just for whatever reason, just to be different.
So I was looking for the difference between X and Y.
Yeah, it's like if they would have given us, I think they do, don't they? Hold on, let me see. I thought they do give us a side. No, that's something earlier. So if they would have just given us a side view of this, which you can kind of give yourself. So here's the point X and here's the point Y, right? So this is 5,100 meters apart here. And then we just figured out what the elevation gain was 750. So what's the slope? Change in Y divided by change in X.
Okay.
I don't care if they would ask me, how far did we actually walk? Then I'd want to do the distance formula because now I want to know how long that is. The grade is just sort of like, well, how steep is it? Not how long is it? Yeah.
Okay. Kind of.
Did that picture not help?
I think I get it a little bit better.
So it's rise over run, just like we do with between points. Yeah.
And then I was going over the practice final exam and number 4 on it. And it's a scale again, but it's like a scale of 0 question mark.
Hold on, let me see. Number 4.
Yeah.
Oh, just O, it's called O scale. I just wanted to put something down. It's just called O scale, not 0. That's the letter O.
Okay.
O scale means the models are made using a 1 inch to 4 foot scale. So 1 inch on the model is 4 feet in real life. That's a standard scale for model train stuff. Come to find out.
Okay.
I think I had just gone to the model train museum at Balboa Park when I made this. So I looked it up and because I was talking to one of the guys there and he was telling me all this stuff and I looked up O scale because he said something about O scale. I was like, oh, you just got to convert 4 feet 8 inches to in real life to how many inches it would be on the model.
Okay. I think I understand that now. I was like 0. What am I supposed to be doing with this 0?
That's
Isn't
O.
0 0?
That's
Okay.
an O scale. Yeah. My fault. I didn't even think about that. I should have put like a hyphen between there or something.
No, it's all right. It's all right.
Okay. Because otherwise
you
you're
have
like
office
0
hours
scale
today?
and everything's 0, huh?
You have office hours today?
Yes, 2 to 3, right?
2 to
2 to
3.
3, I think it is.
Okie dokie. I'm gonna try and play catch up.
Okay. And
All
you'll
right,
see
thank
that.
you, Professor.
All right, welcome.
Bye.
Bye.